Hello, everyone. Today is June 6th, 2024. My name is Maciej, and I'll be your host today. And this is our bi-weekly uh, batch working group meetings. Uh, we have several topics on the agenda. Marching is first with KJob CTL. Go ahead.
Okay, hello everyone. Let me share my screen. Can you see it?
Yes, we can.
Okay. Can you still see it?
Yes, we can.
Perfect. Okay, so welcome everyone. Uh, I want to talk about a problem and an idea for a solution to this problem that have been going around internally for a moment. At Google, and we wanted to propose some solution to the problem. But before we start development, we would love to get your opinion both on the problem and the proposed approach. Uh, During this presentation, feel free to interrupt me at any moment. If you have any questions, comments, concerns whatsoever, uh, I prefer it that way than having questions at the very end. Okay. Okay. So what's the problem that we are facing? So we have heard many times stories from the user that want to start lots of one-off jobs that have complex volume storage setup. For example, input, output, logs, binaries, lying on some network file system, S3, Google Cloud Storage, and things like that. The jobs that they want to start differ very little from each other. They have maybe different arguments, image, maybe a slightly different input files, but usually they look very much alike to each other. And because users are coming from academic background and to tools like Slurm, they strongly prefer to start their jobs via uh, command line instead of editing and having thousands of nearly identical YAMLs. And quite often they work along with the other teammates who have very, very similar jobs to run. Okay, so does this problem sound anyhow familiar to you? Anyone? Do you also have something like that? Okay, no volunteers. So uh, let me go to a solution. So our solution to this problem is to have a kind of reusable job templates stored on API server with a command line interface that transforms them into ready to use YAMLs and send them to API server for execution. So what are these templates? They are stored on API server to be reused by team members. Instead of being stored locally, then this could be problematic for sharing. They have some fields set up with admin specified default, and some that are explicitly left blank. Each template has an information which live flags are required to be specified in order to fill the blanks. And we want these templates to support both job set, kubeflow jobs, and other CRAs like maybe array jobs as well. The proposed flow of the use these templates will be as follows. The admin set up the templates, they build the template, set up the storage, and decides which volumes to use. The template is put on the API server in the Teams namespace. Then the researcher selects the template from the list of available templates and pick one that matches the needs, and they see which flags are needed. Then, based on the template and the flags provider, KJobCTL generates the final YAML and submits it to API server for execution. Okay, as I said, we don't have this tool yet. We don't have the document describing it fully completed yet. So these are preliminary details, and we would love to get your comments on the idea and the details themselves. So first of all, as I said, we have these volumes to be shared between templates. We would like to specify them in such a way that uh, they are easy to be reused and easy to be used inside of command line arguments. So each volume bundle will consist of a number of volumes and a set of environment variables that could be used in command line or elsewhere in the job template, and they will point to various location inside of these volumes and mount points, so that the users can, for example, uh, use them as a kind of API when they specify their command line arguments. These mount points could be like a work dir, input dir, log location, and that could be somehow dynamic because they could have a reference to other environment variables that could be set by other entities. Then we have an application profile. Application profile has a reference to the volumes that they would use and a list of supported modes. Uh, and supported mode contains a specific template and a list of required flags for this template to be filled. The mapping between flags and fields in template is hard-coded and specific to choosing application profile mode. The application profile mode could be job, job set, ray job, TensorFlow job, or any other CRD in the future. And the flags would be specific to this application profile mode. So flag specific to ray job, there will be flag specific to ray job, there will be flag specific to jobs, job set, and so on and so on. And the admins, while setting up the templates, they will decide which fields in the appropriate template they left blank and which fields require users to be filled. And on top of this flags and environment variables that come from volume bundles, there will be kind of a set of predefined additional environment variables that are not present in Kubernetes right now. For example, the information who submitted the job for execution, job task name, so that the pods know who they belong to, unified timestamp passed to all pods, and more in the future. The idea for command line interface is to have a queue plugin called KJobCTL, which would be managed by Crew, the plugin manager, possibly with a wrapper script called KJobCTL for shorter execution. There will be commands in this plugin for creating jobs, starting interactive shell with volumes, and environment setup so that you can check whether all things point to the right places before the job is actually started. And of course, some management tools for listing and describing application profiles along with the required and supported flags. An example command line for starting a job would look like this. So we would like to create a job based on application profile called job in the namespace of Tiger team, and would like to pick profile called analysis, and we are passing some of the flags that the admins called marked as required. So command line, parallelism, completion, request for the main containers, as well as queue queue name from queue. Okay, next steps. Assuming that this thing gets positive feedback, we would like to start developing it in Q's repo, mainly for incubation. We would like to follow the official CAP process inside of Q and start initial development in Q, but soon move it to a dedicated repository. Any questions?
Yes.
Yes.
Hi, Olivier, here, IBM. So, this is very interesting, and obviously we face a very similar problem, and we have developed also kind of our own solution for this, which I'm happy to describe in a minute. Essentially, and that would be maybe my main question is our solution is based on Helm and Helm repos as a
Mm-hmm.
templating mechanism, the validation mechanism, and the sharing mechanism, ideally. So I would ask how you would compare and contrast these two things. Now, a couple of points related to that, which is, yes, we also absolutely see people asking for CLI interfaces, which is not necessarily what, Helm is more like a key value file, right, as input. But the challenge with a CLI interface is that this is not just the ask. The ask is a CLI interface that is the one from Slurm or LSF, right? If the flags are all different and novel and invented for these, then I think there's much less value to the CLI interface. One more point and another question. So the one point is one thing maybe I would, I guess, strongly disagree with in what you presented is to say that the admins are responsible for the templates. Yes, there's a persona that is responsible then for the template that is not the end user, most likely, but it's not the kube admin either, right? Is a super user kind of persona. But it's an AI person, not a kube person. Or it's a union of the two because you have volumes and so on and so forth, right? So it's a very specific persona that is definitely not the cluster admin in our case. And so I have one question. You said interactive. I'd love to hear, because interactive is also a very big question in this context. You just briefly mentioned that. I'd love to understand what you mean and what you're planning to do with interactive in this space.
Okay.
Sorry
Okay.
for the dump, but this is interesting, and yeah, there's a lot to discuss,
Lots
I
of
think.
questions. I put them each on the stack, so I will do them in reverse order, if you allow.
Sure.
Okay. Admin. Why do we think that admin is needed? Because we set up quite a complex environment. There is lots of volumes and mount points that could go wrong. There is a lot of environment and variables flying around that could go wrong, and users would also like to, for example, to access NFS storage or S3 storage, just like their future job would do. So for that, we would be starting a standalone pod that would have all of this environment set up with a shell, with the specified image, and users would be allowed to SSH into this environment, and I don't check directories, check whether the binary is there, and so on and so on.
So you expose the pods. You configure firewalls and so on your clusters so that people can SSH to these
It
pods.
will be like kubectl execute -e.
Exact. Okay.
Okay, so it will go through regular interactive shell path in kubectl. So no extra firewall holes whatsoever would be required. So as long as you can do interactive sessions with kubectl, that will be it. The main trick is that you will get the session in the environment that is very, very close to what your job would be in. So if you have problems with starting, some environment variables don't match, or volumes are mounted in wrong places, you will be able to do it. Plus, after the job finish, you can just start the interactive shell, get into logs or output, and see that the output is there in relatively easy fashion. Okay. What was the previous question?
I mean, the main question is Helm. How do you compare?
Why not Helm? So partially well, Helm is also like an option to move forward. One of the reasons why not Helm is that if we put templates in the API server, we've got earlier validation. So at the moment that you specify the template, it is possible to validate that all things are there and they match criteria, the fields are named properly, and so on and so on.
So you validate the templates as opposed to validating the instance. That's what you're saying?
Yes, validating the template plus it creates easy way for multiple users to access them using regular Kubernetes mechanisms. So you can create templates that are specifically for the team in their namespace, and they can list it and share, and so that you don't need to, I don't know, distribute them or put on GitHub. They're all in API server, but I agree it could be also solved with Helm. It's just like a design choice at this moment.
Okay. I don't want to hold the conversation. I see other hands, so happy to discuss more, but yes.
Okay, Andre?
Yeah, hi Marcin, hi everyone. I think this is great. I think I can, first of all, just give you a little bit of context. I think I'm part of, notebooks team here at Apple, and we see a lot of, interactive use cases and how the scientists view their experience. So my question is like, we've done a lot of, simplification on the Python side, because from a data scientist persona perspective, like usually they just want to work with Python, like they usually, want to code their, like their models on a notebook, then they want to scale it on multiple GPU machines, and then they want to get the results to do the fine tuning. So I think my question is like, sometimes data scientists, they even want to bundle some sort of the, like passing their function to the job or passing their tarball to the job. So my question is like, how do you view the experience for data scientists using this plugin to simplify the job submission, specifically on the container building stage? Any ideas? Any thoughts?
So we were thinking that would not be simplifying container building stage, but we would allow you, for example, to put your extra files on an NFS or anything that could be picked by the container. So if you want to pass some extra arguments or have some extra scripts, you could place it on some storage that is available for the users. Plus, we were also thinking about application profile that would put it into, for example, config map. Like take your script, put it in config map, and mount it on the convenient location with your job, so that if you want to pass it, you have like a foundation image that stays, and you can provide some extras either through NFS or through config map or whatever is more convenient for you.
Yeah, I think the config map, it's interesting, but I think the problem is sometimes, I mean, I'm speaking about specifically data science persona, right? Like data scientists. Like sometimes it's hard for them to define everything in a single script, right? Because maybe they have maybe a very complex model, where they have different like submodules, where they have a different like unit test. And I think sometimes it is required for them to build an image. But the problem is like they don't maybe know how to build an image, right? Or how to properly configure the runtime. So I know that, for example, like Gray allows you to pass a function in the workers. So sometimes it also doesn't work. Sometimes you have to like build a bundle, maybe like they're passing the tarball or, like pre-build the Docker image for their code. So I would love to, hear some ideas from your perspective to simplify this experience, right?
Okay, so
Yeah.
part of inspiration was coming from Slurm. So in Slurm, you use
Yep.
NFS storage, and if you have a number of I don't know, Python scripts that you want to use, you just put them in the directory and you refer directly to them, and you don't bother to create like a very specific image with those files only. So as a partially this effort is to move Kubernetes a bit closer to Slurm. We at Google have a number of users who love Slurm, but they also are interested in Kubernetes and they would like to pick the best of two worlds. So command line and Kubernetes flexibility. And they would like to also to stay with their Slurm type of workload. So they work on NFS storage. They have all the files there, and this NFS storage is also accessible from the task they are submitting to the cluster to be executed. So for this type of people, basing their binaries not on containers, but on a hybrid of base container plus NFS extras or config map extras or whatever is more convenient, I think would be a viable plan. But if you have other opinions, I would be happy to hear them.
Yeah, I think it's great. Thank you for sharing, Marcin. I think it would be really nice to. I don't have a lot of expertise in Slurm, but if you can share some of the examples how like does it work, that will be really helpful to understand. Yeah, thank you. And I think let me.
We
We have
will
some more
do it
questions.
in cap shortly. I'm just pitching the idea here, getting early feedback, but we'll definitely post a more elaborate cap with all of the examples and explanations how these environment variables are going, what are the APIs, and proposed CLIs shortly.
Also, just one more thing, like I would love to learn more about interactivity that Oliver mentioned, because interactivity, I think for different personas is different. What's person from HPC think about interactivity, what folks from data science community think about interactivity is completely different, right? So maybe we can have a follow-up session. How do you view this interactivity? What exactly we can offer for different set of users? So I think that also would be really helpful.
Cool. Yeah.
Thank you.
I'll go next. Oliver was lined up afterwards. I'll build a little bit on top of Oliver's questions with regards to using Helm, but I would broaden this a little bit further. The first thing that came to my mind was Customize. Helm was the other one, but then there are multiple other templating mechanisms that already exist and are widely used in the broader Kubernetes ecosystem. So why then we would need another one? The first issue that I pasted in the chat is, first of all, years ago in the early days of Kubernetes, the idea of templates was being discussed. And if you scroll through that issue, at some point in time, Brian Grant even lists a set of available templating mechanisms that you could use, and both Helm and Customize are being there, but there's also like a handful of others. Not sure how accurate that is. I haven't checked from when that comment is. And as a add-on sort of, OpenShift has a mechanism of templates, which was one of the reasons why we were discussing bringing this topic into Q back then. But I remember it was rejected, and the general sentiment was that it's hard for us to express the ability of having like a generic resource, which was something that we were discussing. So before pushing forward with this, I would try to look into what are the gaps in the existing solution, especially if you, for example, if you pick, I don't know, Helm, Customize, whichever templating mechanism, and combine that with some kind of CI/CD flow for simplicity of using for various users, such that they will be limited with the ability to pick from the pre-existing solution. But a lot of the stuff will be done for them automatically, but without the necessity to build entirely new tooling, which would be in a lot of ways duplicating the efforts of all the other tooling. So I'm not sure that that's a question, but more like a statement to have a closer look at.
But yeah, I definitely appreciate your opinion. As of the question part, yes, there is a number of templating mechanisms that could potentially be used here. Why something different? Because we don't necessarily want to have a generic templating mechanism that could template arbitrary things. We wanted to have a templating mechanism with very strong connection to the flags that will later be used by the user. So I care less about being generic and more about being specific and more convenient for the user, so that we have dedicated flags to fill the templates with a proper validation there per flag, so that the users don't need to worry about the exact syntax. They have proper documentation for these flags and so on and so on. They can list the flags easily, rather than having like a super generic templates that could template arbitrary everything, but would be cumbersome to use by the researcher in command line. So this tool is not for Kubernetes expert. This tool is not for Terraform expert. This tool is not for Helm experts. It's for researchers who don't have DevOps experience. And what they would love is to have something like Slurm, but on this bloody Kubernetes thing that was enforced on them. So that's why we choose to be less generic and more specific, so that we meet our target customer, who is not the admin, who is familiar with Helm's, Kubernetes, YAMLs, whatsoever, but with those people who spend 20 years in academia on Slurm clusters, doing rocket science, and now they are doing some LLMs for real money. So that's why it's not like generic template, and it's mostly flag centric. So we want to have as good flags, easy access, and maybe slightly less convenient experience for the admins, but that would be like a one-off experience with setting it up. And then it will be convenient for the end users, researchers, multiple times. Okay, does it answer your questions and maybe ease your statement?
Yeah, definitely. Oliver has some follow-ups as well.
Cool. Oliver?
Sure, yes. I mean, okay, again, multiple. I guess one, I wanted to follow, I guess, what Andrew was saying earlier, which is, yes, we, it's also the case we absolutely see the shapefile system as a key to usability here. In fact, not just a shapefile system for holding the jobs or the logs, but also to a degree for checkpoints and things like that. So we use GPFS in our case, and that makes a big difference. Now, having said that, GPFS typically will extend on the cluster, will maybe extend to logging nodes, or things akin to logging nodes in a more traditional architecture, but not to laptops. And so then there's this Ray question of how do you Ray submit, maybe, but so far, I think the backup plan, if you don't have the share file system, is Git, right? Is Git commit, Git clone, is having images that or running scripts in images that starts by git clone pip install kind of thing. So we spend a lot of time figuring out the right in quotes base images or base images. Few, not very many of those, because they're big, they needed to be cached, they needed to be loaded efficiently. But then the on top of it, there's this quite, nobody uses KO, for instance, in this community, to, as far as I know, to build fancier Docker images. The Docker images are one persona, and the more the user/data scientist persona will build on top of the image, but not as an image, just as a customization on start, right? And that may be less true. I mean, that's definitely true for long running jobs. If you have really short running jobs, maybe this is inefficient, and we need to look at other solutions. But for long running jobs, this seems to be the de facto standard in what we do. So just wanted to contribute that. I don't know if people have similar experiences.
Okay, I probably missed the question part. I
No,
agree with.
Yeah. The question is, do you see vastly different ways of customizing the environment in which you run, in which jobs run?
So for my perspective, it depends from customer to customer. Some of them have one way, some of them have another way. We're trying to provide something generic that, let's say, serves 80% of them. If you don't have NFS, there is plenty of other volume types that are supported by Kubernetes, starting from Git through config maps, through whatever crazy the thing they put up recently. Like the list has, I don't know, 20, 30 items on it. So something to actually provide the script instead of putting them to container would probably be possible. Plus, well, this thing also works with container. However, if you have to build your own container, then half of the benefit of having a simple CLI is already kind of lost.
Agreed. So do you see? I mean, maybe another question. So again, going back to interactive. So what you described earlier was interactive, as in kubectl exec, as in I have a shell inside of the pod, right? Do you see interactive as I'm still running commands on my laptop, on my my dev environment, but then every command's run. Every command is essentially trigger some execution on a target pod, right? Because yeah, I mean this.
It becomes tricky if you have multiple pods. So if you have one pod, that's fine. The interactive session is kind of obvious. You can execute many commands. In fact, you could do your computation inside of the interactive session and it will be fine. The question is what to do if you have 100 pods. How do you mix the output? What do you actually submit to those? How do you deal with some pods being still executing, some of them don't? So it becomes complex. So from that perspective, like single instance jobs could be executed in interactive mode. Multi-pod jobs are tricky, and I'm not sure if we made it possible that the end result would be convenient for the users, actually.
Because again, this fundamentally goes back to where is your dev environment? Is it in the pod or is it in your laptop, right? And challenge is, if it's in the pods, is that you're going to want Visual Studio Code, for instance, to actually be using the environment inside the pod, right? Can you do that with kubectl exec? I'm not sure.
No, you probably cannot do Visual Code. Maybe you can do Vim or stuff like that.
That will work for
If
small.
it's your environment of choice, then yes, but I haven't heard about people doing visual, graphical sessions with kubectl exec. Maybe it's possible, but I haven't heard about.
It's not in that case. It's not. I mean, but I think interactive is a key question here, and there are some incomparable choices, right? So trying to, I think that's one thing I'd love to see. If the cap goes into that, I'd love to see the cap be really more specific about the use case and how this can be used. So in the particular I'm taking the example of VS Code because it's not like VNC, right? It's not like actually running. It's not running the environment in the pod, but it's having a server running in the pod and having the UI, the GUI actually connect to the server remotely, so that every file is actually on the remote system. Every command that is run is in the remote system, but again, the interface is still running on your laptop, right? So that's a kind of ad hoc, maybe mechanism, but very, very, very convenient in practice. Very, very popular because it's from a user experience perspective, nothing changes, right? It's like, so you can have a remote environment, you can have a local environment. Essentially, you have the same experience, right? So that's very powerful in that sense.
Okay.
Yeah, in the
Thank-
interest of time, I would like to, because we still
Sure.
have Aldo
Yeah.
and Yuki. I don't suspect they're needing more, but they should be able to fit in the remaining 20 minutes. So
So the
yeah,
quick
go ahead.
answer for your concerns, yes, we will think about it. Hopefully, they will be addressed in CAP. And now I'd like to give the floor to the remaining people, if you don't mind.
Cool. Aldo?
I actually have a quick question, but for Olivier and Maciek. These tools that you already have for templating, what are the projects? Are they open source?
Oh yeah,
What are the names?
the templating is a mechanism available in OpenShift. It's a rather simple thing because what we basically keep is we keep the resources as part of the template. The template is another resource within the Kube API. Even though it's defined by the OpenShift API server, you could probably find it on GitHub easily under OpenShift API, what the template looks like. And it does have some very basic validation mechanisms for the parameters, and you can specify which are required, which are not. So yeah, it's one of those mechanisms that has been part of the OpenShift from day one, basically.
Okay. And so on the storage is on the API server
Yes.
as
Yeah.
opposed to like
Yeah.
GitHub
Correct.
or something.
Yes. Correct.
Okay.
You basically have another resource on the Kube API server, which allows you to share the resource within your cluster.
And what I was talking about was just pure Helm. So really, the only thing is curated templates. And no, some of these are not open source; they're specific to our clusters. But these are just regular Helm templates, right?
And they store in a repo.
And they're
somewhere.
stored in a repo, and they're, yes, there's some structure. Maybe we try some patterns we try to have to reproduce in terms of validation and so on. But it's also, I would say also it needs a lot of work before it can be really useful to a larger community.
I think, thank you. I need to join from my laptop so I can present. Okay. Can I have permissions, or do I already have permissions?
You already have, I think you joined as a lead.
I did. Okay, share screen. Okay, so I just wanted to give a quick update on Q 0.7. We don't we we don't have to go through all of this. I presented yesterday at CNCF research user group, so I prepared these slides. But a lot of these things you already know. You know what queue is. It's a job queuing system that has a quota management in a two-level hierarchy. We support priorities, preemption, and we have this concept of resource flavors that allow to express fungibility. So the ability to burst from certain models or VM availability models, to burst from one to another. And we support multiple APIs in the ecosystem, but primarily Job and JobSet, which are Kubernetes projects, and also Kubeflow and Kuberay, and more recently PlanePods. And we've been collaborating with Olivier here to better integrate our wrapper and in general improving the documentation on how you can integrate any CRD with Q. I'll skip this one. Maybe just real quick. So we have two personas, an administrator that creates the clusters and the quotas, researchers that creates the jobs, and then Q will take those two things together and do an admission process. And when it admits, it will inject some node affinities and start the job. Now, in between this process, we have recently introduced two mechanisms for extension, namely the cluster autoscaler provisioning request, which allows Q to send a heads up to the cluster autoscaler that a job of a certain size is coming, and then cluster autoscaler scales up or holds the resources, providing a notification back to Q, and then Q is able to start the job. Another extension mechanism is what we call multi-queue, which allows you to send jobs, allows Q to send jobs to different clusters that are allowed that are configured for Q. Then once Q admits the job, then the regular Kubernetes takes over, Kubernetes creates pods, cluster autoscaler provisions more nodes. If it didn't so before, the scheduler schedules pods, and then finally kubelet will run the pods. I'll skip this one. So what's new in 0.7? Also, just a quick review of 0.6. So the biggest thing in the new release is fair sharing, which is the ability to divide the resources equitatively between the users or the queues, whatever you define. And it's also weighted. I'll explain. I'll expand on this a little bit more. Another effort we've been working on is multi-queue. Again, so this was released in 0.6. In 0.7, we closed some gaps. We improved the support for JobSet, and we started working on the support for job. However, the support for job is pending on the release of, I guess now, Kubernetes 132, because it uses one new feature in Kubernetes, which is called manage by, to be able to have full synchronization of the job status in multi-queue mode. For now, the synchronization only happens once the job finishes. We've also been working on the integration with provisioning request that is a cluster autoscaler feature. And we have been working also within cluster autoscaler itself to implement certain engines for provisioning in cluster autoscaler. We added two integrations in these two releases, groups of PlanePods. In the 0.5 release, we only supported individual pods, but in the 0.6 release, we also support groups of pods. You just declare as in an annotation whether they form part of a group and what's the size. We also added support for RAID cluster from the KubeRAID project. Another big effort has been scale testing. We did a lot of experiments, which led to improvements in reconcilers, reducing API calls, and so on and so forth. We also found some throughput issues in kubescheduler, so we also fixed those in upstream Kubernetes. Yeah, it was a fun experience there. And more recently, we started a kubectl plugin for Q. This is different from the kjobctl that Marcin just mentioned. This is a focus on Q objects, primarily because the kubectl CLI doesn't allow you to filter on status and things like that. So the Q plugin introduces several filters there to be able to find your objects more easily. And improvements to the visibility API as well. Yes. We also added some metrics for admission time and, and for evictions, so you have better visibility. How much time do I have? Maybe I'll skip. I'll quickly talk about fair sharing. Basically, the fair sharing is based on DRF. However, the DRF is only applied for the unused resources. If you're a user of Q, you might know that for each cluster Q, you can define a quota. So if you define this quota as 40 and 40, and this one, for example, has 60, but the cluster QC is only using 10 of it, then now we have 50 unused resources. So if cluster QA and cluster QB have the same weight, they can both use 25 units extra from the cluster QC, while cluster QC is not using those resources. Now, first in Q, you can also set weights for the fair sharing. So assuming that cluster QA has a weight of 2 and cluster QB has a weight of 3, you could have something like this, like cluster QA is allowed to borrow 20 units and cluster QB is allowed to borrow 30 units because of the weights. This was already presented, so this is the multi-queue model where, well, there is a multi-queue controller that sends the jobs to every cluster that is defined. Actually, it sends initially some kind of ghost job just to get a hold of the resources. Once one of the clusters replies back that there is capacity for running this job, then the multi-queue controller sends the actual job and it runs on the remote cluster. I think I can skip this for now. So what is top of mind for the next version? We want to extend fair sharing to work in an arbitrary hierarchy. Today, fair sharing is limited to a 2-level hierarchy. So cluster queues and cohorts, so the one grouping mechanism. But the goal is to have actually an arbitrary hierarchy, a tree structure defining the teams. You already heard about kjobctl. That's another effort we want to work on. We're also looking into fallbacks and a better experience for falling back and when your resources are not available. And upgrades, which means, let's imagine you have a job, you have a reservation and spot VMs, and your job is running on spots because the reservation was full. Now the reservation has space. You might want to move those jobs back to the reservation in order to save on your cloud bill. So that's one of the goals of this effort, and we are continuing to invest in the cluster autoscaler effort to have more engines for provisioning. So we're looking for feedback. You know already all the channels to provide this information. Well, yeah, let us know you try 0.7, and if you find any issues, please file them on GitHub. So I guess there is no time for questions, but
Yeah, not much unless Yuka will be finished ahead of time, but I would like to give him some time for his topic. So thanks a lot, Aldo. Yuki, go ahead.
Yes. Okay. So
Do you want to share your screen?
yeah.
Okay, I just made you co-host. You should be able to share.
Thank you. Okay. Can you see me?
Yep, we can see your screen.
So let me describe background this job success policy feature. So this feature, so we introduced the Kubernetes B1.30 as alpha feature, and so I would like to graduate this feature to beta stage in the next 1.31 version. So the quickly, so main discussion point is so actually, so in alpha feature stage, we have some remaining discussion points. So the first one is yes, here. So the first is so if we should introduce a new another field when criteria achieved field, and the second is so if we should introduce a current job new concurrent policy, and the third one is so yes, configurable reason for success criteria met condition. This is similar to portfolio policy configurable reason. But so I would like to leave these all additional feature in another or other features, because so the three additional fields and functionalities does not have enough real use cases. So so my question is, is there anyone so having real use cases against these three features? If not, so I would like to drop these three features from the job success policy feature. So what do you think? So
I'm not sure about the use cases for for the when criteria achieved. But for the second point that you raised about forbid until successful, I think we are doing this sort of anyway, but because we are slightly changing semantic or fixing the forbid mode itself. So until now it was as in MyCap for the managed by, we are actually setting the semantic for the forbid mode to do exactly that, meaning that wait until successful or failed. So until, let's say, all the pods are also terminated.
Yeah, you mean so this can appear, yeah. So updates managed by.
Yeah. So I don't think this success policy cap needs that, because we are solving this sort of any way in a slightly different fashion.
Yeah. So as Mihar mentioned, so actually we don't have enough VR use cases, and so so in managed by so as we discussed the managed by cap so we introduce a new condition transition so against the success criteria mate and completion. So if we want to introduce new new condition, new when criterion achieved fields. So maybe so there are some race. Yeah. So I want to drop this field from the job success policy feature.
So this was not implemented, correct?
Yes. So currently, so in alpha stage, so we didn't implement this field. Yeah.
So I would say if nobody has asked for it, we can just drop it. And I expect that I feel like this feature is possible to add later on if needed. So if that's the case, we should probably just proceed without it.
So you mean so if we drop this field, so we have we will have some negative feedbacks.
What I'm saying is that we can wait for feedback. So we can release as we have the feature today, and if there is need for, if people express feedback that they need this additional condition, then we can probably add it in the future. If we haven't heard from users that they need it right now, then we can probably drop it.
Yeah.
Yeah, I agree, and I also think we, let's say, in the third case you mentioned about the customizable reason, so something that we do for pod failure policy, but we do this as a separate cap. Let's say there is no harm to do this always as a follow-up cap rather than prolonging graduations of this, at least in my view, especially if we don't have, let's say, good use cases as of now.
In the interest of time, if you have any suggestions or questions or suggestions, please leave them in the cap that is linked in the agenda, so that we can continue the discussion in the cap
Yeah, sure.
where this is going to happen. Okay, cool. Thank you very much all for today, and see you next time. Bye all.